Hi friends, this is Dr. K. Muralidharan, a senior professor of Maharaja Sajirao University of Baroda and an adjunct professor with IIT Gandhinagar. From predicting weather patterns to modeling customer behavior and even Google's PageRank, Markov chains are behind some of the most important algorithms and systems we use every day. Let's explore the core concepts that make these. Okay, let's understand a stochastic process first. Any random process which depends on time of its occurrence is called a stochastic process. Because it is random, we call it as random process or dynamic process as well. So generally stochastic processes are denoted by xt in t in suffix, where t element of capital T or x of t in bracket here. So these kind of notations are generally used, where capital T is the time space and xt or x of t is called the state space. Can also see that xt, both xt and t can be discrete and continuous, discrete time, etc. So a Markov process for which both state space and time space is discrete is called a Markov chain. Okay, let's understand the Markov chain concepts in detail. So suppose xt is a stochastic process defined for various values of t. The Markov property assumes that the dependence of xn does not extend beyond the immediate predecessor x of n minus 1. That means for a given values of xt, the values of xs where t less than s does not depend on the values of x of u where u is less than t. So thus x of s become the future event here, x of t the current, and x of u become the past. So in short, Markov property is stated as given the present, future is independent of the past. And any process satisfying this process property is called Markov process. And a Markov process for which both the state space and time space are discrete is known as Markov chain. So technically speaking, the language is very simple. So given all other events, probability of xtn equal to xn is simply probability of xtn given xtn minus 1, because rest of the events are treated as past. So this is considered to be the defining characteristics of a Markov. Okay, let's understand Markov chain further with some examples. So Markov chains are powerful mathematical models used to describe systems that move between different states with certain probabilities. For instance, the pattern of a day, which changes from humid to rainy or hot or something like that. And during an entire day or entire month, if you want, you can get that way also. Situation of a patient, number of students admitted in various courses or faculties, students' situation of price of stocks, and so on. So, so Markov chain can be of any order, because the transition can take place in any number of steps. So one step, the beginning, the homogeneous Markov process is defined with the one-step transition probability. It's simple. Pij is equal to probability of xn equal to j given xn minus 1 equal to y, and so on. And in nth stage, our n-step transition probability can be defined as Pijn is equal to probability of xn equal to j given x naught is equal to y. So what is so special about transition probability then? So the matrix P or Pij is called a transition probability matrix if the all elements should be positive. The first condition says all elements should be positive for every I and j, and row sum is equal to 1. That means summation of Pij, where summation is taken over all j and for every I. That means each row, the sum should be 1. So look at these matrices. Even identity matrix is also a stochastic matrix, or even transition probability matrix, where unit is seen in the diagonal, and of diagonal it will be zeros. So that's also possible. So if the column total is also 1, then you can say that it is doubly stochastic. Okay, so let us understand the classification of states first. So a recurrent class is, that means a state once moves can be revisited again. Transient, where state moves and will not never be revisited. Absorbing means it's once entered, it cannot be left. Periodic means return occurs at fixed intervals. So period can be 1, 2, or more than that. So one, if it is 1, if you may say it's a periodic, and if it is more than 1, you may say periodic with some period number, maybe 2, 3, like that. And a Markov chain is said to be ergodic if it is irreducible. Irreducible means if there are many states, if there is three states, all three states can be communicate with it. If there are more than one three states, means all states will communicate, means revisit each other. That's the meaning of irreducibility. And a periodic we have already spelled out, and has a stationary distribution to which is that to which it converges regardless of the initial stage. Okay, so finally it goes to a constant probability. That's why it's called a stationary. And another interesting property is the steady state distribution there, or stationary distribution. So that can be easily obtained if P, capital P is the transition probability matrix and pi is the initial matrix, then pi p is equal to pi, equate and you find the value of pi. So that becomes the stationary probability. Okay, so let us now understand the whole the application of Markov chain to a medical example. So generally we see doctors and health researchers often need to predict how often a patient's health condition will evolve over time. For example, how likely a patient is to recover, stay the same, or worsen, etc., etc. So Markov chain helps to model this kind of stuff situation. So let us understand. So the state space is given as the healthy, mild, severe, or dead. So it maybe you can even denote it as 1, 2, 3, 4 for simplicity. So that will be more readable if you do that. And the transition probabilities matrix is given on the other right side. So let us understand some of the elements here. Say the first element P1, but the first element, first row, first column element 0.85. That means a healthy person remains healthy with 85% of the chances this year. Similarly, 40% of the severe cases will remain, eventually die. That's the meaning of 40.40. So, and so on. Technically speaking, the 85% can be represented this way. P11 is equal to probability of x1 equal to 1 given x not equal to 1. It's the same notation we have used earlier. It's a one-step transition probability. So where the state moves from first to first with this one in one step. That is 85%. That is 0.85 and so on. So what will be the interest here for the health personnel? So they may be interested to see how to predict the future health, what the status of future health, etc., and estimate life expectancy, comparing treatments, maybe even more than two treatments. Also, we can compare healthcare cost analysis if you are interested in some management aspects. So all this will be the interesting part of the health personnel. So here are some of the questions. Let us answer that. So what is the status of the illness on second, fourth, and eighth year? It's very simple. Get the higher order matrices like p square, p raised to 4, p raised to 8. And you can easily understand the way you have understood how the p is in p, the matrix p is interpreted. Same way you can interpret p square, p raised to 4. So if p is for current year, then p square becomes the second year, p raised to 4 becomes the fourth year, p raised to 8 becomes the eighth year, and so on. So that's how you can do that interpretation. So similarly, moving on to further questions. So what is the probability that a healthy patient eventually die on second, fourth, eighth, and 10th year? It's as good as getting the element correspond to 1/4 in from phi square, p raised to 4, p raised to 8, and p raised to 10. So further, you can even classify the states like transiency, transient, absorbing, and recurrent. Here, 1, 2, 3, all states are going to be transient because there is a possibility to, there is not guaranteed to return actually, so that they become the transient states. 4 is absorbing because the diagonal element is 1, so once there it is entered there, it will not move further. Periodicity. So very another important property of Markov chain. So it's calculated as the GCD of a set where n greater than equal to 1 such that pi n greater than 0. So here healthy state we have computed the period. It is going to be 1 because everywhere the GCD of 1, 2, 3 set is going to be 1. Similarly, mild and severe is also a periodic. And death state, because of convention, it's an absorbing state, so period also become 1. So the conclusion is that the chain is aperiodic and absorbing, meaning that starting from any transient state, the process will eventually reaches the absorbing state without cyclical fluctuations. So let's move on further. So we have to now calculate some stationary probabilities and number of steps required to reach to the final stage like death and so on. So let us compute, let us partition the matrix P in the form Q, R, 0, and I. So each are matrices and they are shown the compute capital N as 1 minus Q raised to minus 1. and then that is multiplied by 1. 1 is a unit matrix that become T. So that you will get the number of steps required for absorption from a transient state. So only transient state absorption probabilities numbers are shown here using the calculation. So that means it takes 11 steps to absorption from healthy state. Similarly, 6 steps from mild and 2.5 number of steps to reach the absorption to death from a severe case. So similarly, you can compute B as N into R, capital N into R. That becomes the probability of that the chain will eventually be absorbed in the absorbing state to death, starting from the transient state here. So you have all the computations, all the important quantities computed here. So all this will help you to answer many of the medical related questions here. So another interesting question to be answered here is the survival probabilities. So it can be easily calculated as 1 minus probability of Xn is equal to death. So that becomes the survival probability. So Sn is computed as sum over all those transient states I, P naught into P raised to n I, where P naught is the initial probabilities. That is also given here. You can assume any probabilities and you can compute and see how it's going to be eventually happening. So this is the total probability of not yet observed after n steps. So 1 minus p of that, that's 1 minus of that becomes the probability, I mean survival. So for different n, 5, 10, 15, or any number in between, you can find the probabilities, survival probabilities here. So S of 5, for n equal to 5, it is calculated as 0.7614. That means after 5 years, about 76.1% of individuals are still alive. And still alive means they can be in healthy, mild, or severe case. Though that's a different this thing. But even then, we can find the healthy that is going to be 0.4437, and mild that n equal to 5 is 0.1977. So individual probability is also shown there. So but 23.9% of the cases will reach the absorbing state. And similarly, S of 10, n equal to 10, 15, 20 also is calculated. And you can see that the probabilities are going down. That's in natural because the survival goes down when you pass on with the time. Okay, so in the same way, you can see many such examples in practical cases, contexts, where queuing system is one, where modeling arrival and service patterns and identifying the distributions. Credit rating transitions, you can see very often done in financial applications. Genetics is another important area where Markov chain concepts are used for modeling DNA sequencing, networking of DNA, etc. Transportation system predicting passenger movement or traffic flow. Machine learning is a very important, upcoming area where Markov chain concepts are used, where hidden Markov models are very often used for understanding the speech recognition and natural language processing and so on. So it is a queuing systems, genetics, finance, or machine learning. Markov chains play a central role in modeling how systems evolve under uncertainty. So you can watch more such videos on my channel, Elucidation and Interpretation. Thank you for watching. Thank you very much.